Can you see the slides?
Yes, sir.
Yes, sir.
Okay. Okay, I understand that they're taking classes in the weekend. It creates problems. But yesterday I could not take the class as I decided earlier. So from next week onwards, I'll try not to take classes in the weekends. That unless it is extremely essential. That is one point. The other thing is regarding the time. 1 hour. If you feel like it is becoming difficult for you to extend, so just interrupt me, and I try to wrap it up during that time. And today it will be just 1 hour class as per the contents that I have prepared. In our last class, we were talking about the use of the new and delete operators, and this is the summary of what we discussed. And we also talked about allocating two-dimensional arrays completely dynamically. We face the problem of dynamic allocation. The problem means intuitively what you expect that was not working, and we ended up with a strategy that can be used to actually allocate the rows separately and then store the base addresses of each individual row of a 2D array in another array of integer pointers. So that was the strategy. So this will once again review, and we'll continue with the other options where the number of rows are known but the number of columns are unknown, where the number of rows are unknown but the columns are known. So all the different possible variations, and we'll see that how we can have a very efficient allocation given the requirement or given the problem scenario. So just to summarize, so this was the code for one-dimensional array allocation. So this was pretty simple. So now if I write here int a5, so this means static allocation of a 1D integer array. If I write what does it mean? Tell me quickly. What does it mean?
So what did you write before? It's a const.
Const.
Okay. Sir, it means that the array is initialized as a constant itself, like the null value is a constant itself, cannot be changed.
So this means what? So this is a 1D array. So this is a one-dimensional integer array. This is a static
So
allocation. First of all,
it can't be updated, sir. It can't be
yes,
updated.
but the first thing is these are static allocation of one-dimensional array with constant integer values, right? Hello?
Yes, sir.
Yes, sir.
So if I write here this, what does it mean? So I'm just reviewing this before I get into the actual problems today. So what was this? Tell me quickly.
Dynamic allocation 1D.
Dynamic memory allocation of one integer element. Dynamic allocation of one integer element. It's not an array, just one integer element. So if I do this, what does it mean? What does it mean?
Sir, it means that the pointer is constant.
Dynamic memory allocation of one integer
One
element.
Constant integer.
One integer, one constant integer element, right? This is what it means. Is that fine?
So
Yes, sir.
But constant should be initialized. So what should I do now? Maybe I write this. Is that okay?
yes, sir.
So now, so we know that I can just allocate. If I want, I can allocate and initialize. That is also possible. Now if I write how do I read this?
Sir, the dynamic allocation of one integer, an integer array of size 2, sir.
Dynamic allocation of one dimensional integer array of
Of size 2.
size 2. Okay, so this is fine. Now if I write here like this, so this is okay. What does it mean? Anybody else? Like only 2 or 3 of you are responding. Others, can you any of the other students? What is this? How do I read this?
It's an integer of it's an array of integer pointers.
Yes,
Array
sir.
of integer pointers. So the
Yeah.
thing is, and how many? Array of 2 integer pointers. It's a one dimensional array of integer pointers of exact size 2, right? It's a dynamic allocation. So it's a dynamic allocation of a 1D integer pointer array of size 2, right? So this is what do I specify here in each of these cases? What do I specify here? Okay, so here these are, what are these? These are the types, right? Type of the element. And here what do I specify? This is a number of elements. So then we specify, if this is the case, this means the number of elements. And if this is the case, then the initial value of the element. So here this means the type of the element, then which is followed by either this or this one, and the whole thing is preceded by this new operator, right? And depending on what you are doing, so first of all, is this statement correct? Who just now responded? So is this correct? Hello?
Yes, sir.
Is this correct?
Yes, sir.
Anybody else? What is this? This is a 1D integer array, right? 1D integer array, and this is 1D integer pointer array. So the base address of this array, so you see this array is integer array, and the base address is pointed by P, right? So what are the elements here? These are integers. Now in this case, what is this? This is a pointed to integer array, right? So these are not elements, they are pointing to integers actually. So what is this? This is integer pointer, right? And P is pointing to this one. Now tell me, is this correct? Who P is pointing to?
No, sir.
Are you getting me? Hello?
Yes, sir.
So tell me the correct answer. Are you getting me what I'm discussing during the last 2 classes? So here this P is basically pointing to the 0th element of this integer array, simple integer array, right? So basically P is a pointer to integer because this is an integer. But in this case, P is pointing to an array of integer pointers. So here P stores the address of the first element, which is an integer pointer. So is this correct, this part?
In the star.
So it should be star star, right? So this is not correct. Got the point?
Yes, sir.
So you should not just look into here. So you should know that whether the array that you are allocating or the element that you are allocating, the address of that is compatible to this variable that you are declaring. Is that okay?
Yes, sir.
So now if I write int asterisk say q new float asterisk float asterisk asterisk 3. Okay, first of all, if I simply write this one, what do I expect? If I assume this is to be correct, this portion is correct, how should I interpret this?
So basically a pointer to all arrays with size 3 of type float. Sir, a pointer to all arrays that are of float data type and size 3.
Not exactly. Others, anybody else? What is this? What is this type? First of all, what is the type here? Type is a, what is this type? I am asking to allocate.
Pointer, sir. Pointer of a point.
Pointer to float. So pointer to float. And how many elements? So what is this? This is the allocation of one dimensional array. Is that fine? It's the allocation of one dimensional array. You see here, right? Of what will be the type of the elements? Each element is a pointer to float. Are you getting the point? This is an allocation for one dimensional array. You see, because here this parenthesis means number of elements. It's allocation of one dimensional array of size 3. What are the elements? Pointer to float. Is that okay?
Yes, sir.
So this is basically a dynamic allocation of 1D array of float pointer of size of float pointer elements, right? You can specify dynamic allocation of one dimensional array of float pointer elements of size 3. Fine. So this means what it means. So this is an array of 3. What type of arrays they can point to? Float pointer means each of them they can point a. So this can be a 2D float array. Is that fine?
Yes, sir.
This again can be a 2D float array. This can also be a 2D float array. This also is a 2D float array. What is the size of this array? Two-dimensional float array. This one, what is the size? As I have drawn it. How many rows, how many columns? Can you see? Just one
2
cell.
cross 4.
So how many rows? How many? Just one cell, one element. So if I talk in terms of 2D, how many rows, how many columns? 1 cross 1. So this may be 2 cross 1, 2, 3, 4, 2 cross 4. This may be say something like say 4 cross 5. So I never mentioned what will be the size of these 2D arrays. No matter what their sizes are, the base addresses of these two-dimensional arrays can be stored in this particular uh, array. So which one we are allocating? Actually, we are allocating here. So if you look into, we are allocating this part. So this new is basically allocating this part. Here this new is basically allocating this part. Okay. Here this new is basically allocating this part. Is that part clear? But what is the mistake that I have done here? Again in declaration of the queue. So how the queue should be declared? How the queue should be declared? What is the type of queue?
So double asterisk, sir.
Double asterisk. The Q should be pointing to.
Triple asterisk.
The Q should be pointing. Huh?
Oh,
Don't confuse it. Otherwise, are you not getting things, or I don't know. So
no,
Q
sir,
is pointing.
mistake,
Q is
sir.
pointing to an array of float pointer. So Q should be Q is a pointer to float pointer. So Q is a pointer to. Sorry, I mean float point. So this is completely mistaken. There is no integer here. So it should be okay. So that was a trivial mistake. So Q is a pointer to a float pointer to float. Is that part okay? Is that clear, or you have still doubts? I'm asking to the whole class, because otherwise there is no point of proceeding further. The rest of the things you will not be able to get. So it will just be, I keep talking and there is no point of talking.
Sir, I have a doubt in the above
Yes.
declaration. Sir, that type of declaration is not useful, no, sir, because we access pointers of known variables, no, sir. Dynamically allocated means that type
No,
of
I mean,
declaration.
the point is, I am not talking about the purpose here. So what is the point of doing this? I can give you examples where this is also required at times, but let us not. So let us just focus on the syntactic issues and whether you understand how to declare a pointer and how to use new corresponding to that, or how can you interpret. So what is this actually done, or what is this doing? So can you decode that part? Can you interpret that part? That is my question here. And I understand. So you say that what is the point? So there are two. So who knows? These 2D arrays also may be dynamically stored. And each time you get the array stored, the base address, you store it here. You write a function that will allocate two-dimensional arrays dynamically. If you pass the number of rows and columns, it will just do it for you. And it will return you the base address, which you will be storing here like this. So you want a bunch of 2D arrays of varying sizes, right? So that may be the case. Hello.
Yes, sir, understood.
So yeah, there can be many such instances where we need that. So we will come across many interesting scenarios where these are required. It's not just for to have enough knowledge on pointers. It's not because of that. So pointers are indeed required. Pointers and references indeed are required, and there are instances where you cannot get rid of it. I mean, at times you require not only pointers but also constants in a certain way. Otherwise, the programs will not work as you want them to perform. So there are cases. You may not have encountered this till this point. That is unfortunate, but there are cases. I'll give you assignments which will be requiring those things. But try to first know that whether you are able to decode these things, what they are doing syntactically, and also the context of it also. Is that okay?
Yes, sir.
Yes, sir.
I'm asking others also. If you have any doubts, just clear it out. Otherwise, you will simply get lost in the rest of the class and also rest of the lectures that follows. Because object-oriented programming is not just writing a class definition and all this. So this you have done in your school levels. It's fine. But now you have to know, it's not only enough to know the feature of object-oriented language, like I know polymorphism, I know overloading and all this, but you should also know that how things are done internally and what is the impact. I mean, how the compiler realizes internally. Without that, there is no point of, as a computer science student, there is no point of reading a object-oriented language C++. Okay, so try to know this. We'll be able to relate it in a proper time with the different features. Okay, so this part we have done. So this is this static allocation. So in our last class we did this one. If R and C both are unknown, then what happens? So what we found there, if I write R times C, it is completely wrong. Okay, it will not be compiled also, you see, because this type. So this means, so now can you interpret this? Can you say what I have done here? if I simply write R into C there quickly, can you tell me in words what I have done?
Dynamic allocation of 1D array of size R cross C.
R cross C, or say maybe 20 or whatever, what is the value? Now it is a one-dimensional array, and now you are trying to assign the base address of that 1D array in what type of pointer? Pointer to integer. Are they compatible? Are they compatible?
No, sir.
No, sir.
So that's why this error message is coming. So it will simply not compile. Forget about doing some allocation here. Now another one I think somebody mentioned in the last class, that new int, why don't you write R and C? This you tried, somebody asked for this one, right? So this also is not correct, and we found that this is also not working. We'll come across similar situations later on. We'll come to it later on. So what we found is this failed, and finally we got a solution of something like this, right? So what we did, the idea was, here we allocate this array, sorry, this pointer, integer asterisk asterisk, and then you allocate a 1D array of integer pointers which will be holding the base address of the individual rows, right? And these are the individual rows, say for example, because it's a 2D integer array, so all the rows will be having the same size. So they are C rows, sorry, I mean C columns. So C columns, and C columns, and these are the number of rows, right? Both R and C are unknown. So once you know what is the value of R and C, so you first, before you do these allocations, you have to complete this one, because once you start doing this, you have to store the base address of this array somewhere. So first, this is the part A. So you basically do this. If R is equal to 3, so you do this, and then within a for loop, you basically allocate this one, this one, this one. And each time you do this, you basically save the base address here so that it can point to this. You can save the base address here, point to this, like this. So these portions, if I call it, it is done in the portion B. So here, so here, this is the part A, right? What it does, you are allocating integer array, integer pointer array. You are allocating an integer pointer array of size R, right? That is what we did. We just now revised it. Integer pointer array of size R. And because these are another, so what is this A now? So A is this pointer, this is A, okay? So this is actually A. So this must be a pointer to integer, because these are integer pointers. So somebody who is pointing to integer pointer must be a pointer to integer. That's why we have declared A as pointer to integer. So this means this part A is done, right? So this whole thing is part A is done. So once this part is done, now you have to allocate one by one the rows. So that's why I have used a for loop here. How many rows? K equals to 0 to less than R. So as many number of rows as you have asked for. So this value, the same values. So for each row, I am doing the part B. So this is a part B. What is a part B? In the part B, I have to dynamically allocate a 1D integer array of size C each time. So each time, each iteration, it's a, so there is a mistake here, no? So there is a mistake. There's a mistake here. So what is missing here?
So int
Sir.
square bracket C should be.
In square bracket C, I'll make the change. Actually, I have not tested it. I was just testing the syntax, so that's why there was a mistake. I'll make the change. Is that okay now? So that
Yes,
means I am
sir.
allocating 1D array of size C, and the base address of that will be assigned to, in the kth iteration, the kth element of A. So this has done. So this is the the each iteration, this part, this part, this part is, so the whole B is done like this. Once it is there, now this whole thing is basically the 2D integer array, right? And we have shown in our last class that if I write after this allocation, if I write aij, this means a plus I whole asterisk plus j whole asterisk, so they are basically the same, and that will actually, so this is basically asterisk a plus I plus j whole asterisk. So these two are basically the same. So up to this, is it clear?
Yes, sir.
So now once it is done, now you can, as I mentioned, I am reading the values in aij, or I am modifying it, whatever I want, I can do that. I'm displaying the contents, doesn't matter. If I would like to deallocate, so you see I have allocated this first. So as you can see here, this is what, so this part is static, right? This is static allocation, this part, or let me use the green color. So this part is static allocation, right? So where it will be allocated, the space for A, how much space A will require, the pointer A will require, how much space pointer A will require. Any pointer, how much space it requires?
So 4 bytes.
4 bytes.
Integer size.
Because I mean the compiler that I am using, it will be requiring 4 bytes. Your compiler might be requiring 2 bytes or maybe 4 bytes. That we have to check. So in our case, let us assume it's 4 bytes. So which particular segment it will be allocated the space?
Stack.
Hmm?
Stack.
Stack segment, because it's static,
Stack.
right? So static means stack segment. Now this and this, these are all dynamic allocation, right? So these are all dynamic allocation. Let's use this color. So this portion is all dynamic allocation. Is that okay? So this is dynamic allocation. So all these elements, or I mean all the space required by these allocations will be from which segment?
Heap.
Heap segment, right? So if these are heap, so all these will be from the heap, and this part will be from the stack segment, and the stack segment will point to. So the thing is, we have allocated this, we have first, then this. Now if I are going to deallocate this, if I am going to if I am trying to exit from that function and making sure that these garbages are not left over, so how the deallocation should work? So which one should I deallocate first, A or B?
B.
B, sir.
Because if I deallocate A first, then you basically lose track of the B, because nobody knows the addresses of those arrays, of those rows, right? Hello, is that correct?
Yes, sir.
Yes, sir.
Yes.
Yes, sir.
You dispose it off, so you are lost, so you cannot reach them. So the thing is, first of all, you have to deallocate this, maybe in the same order that they have been allocated. And once you have disposed this, you will make sure that now these pointers will not lead to anything that has been allocated. Now you are free to deallocate this one. So that's why I have done, say maybe while I am deallocating, I can write it as say maybe this is D1 and this is say D2. So this is basically D1 and this is D2. Is that okay? So D1 means this is, you see, 0 to R. So one by one, what it is deallocating? A1, AI, basically A0, A1, A2. So first it will, what it is done? A1 or A0 with this. That means the entire chunk of location or the block of location pointed by this A1. So starting from the A1, so A0. So A0 means this. So this whole thing that has been allocated will be disposed. After disposing this, it will take the next value of I here. So it is A1. So A1, the entire chunk, because we have given this parenthesis. So it will not only deallocate the first element, but the whole thing that has been allocated in a single shot. And then it will take the value of I to 2. So A2, that means it will come here and will reallocate this one. So once these are off, so now you are free to deallocate this also. So where to know its address? The base address. Who knows the base address of this array?
A. Small
A knows
a.
that because A points. So now that's why you write here delete A. So A is basically pointing to this one. So once this is done, A still points to this one, but you know this is, so there is no garbage left off. And so the next thing, so the next you know nice the good thing should be like A, you assign it to null, because now A is not pointing to anything that has been allocated, so it's better to assign null to A. Okay, is that part okay? So this we have done in the last class, but I thought of just revising it once again. Is this fine now?
Yes, sir.
Yes, sir.
So this is how two-dimensional arrays are allocated. So it seems to be too complicated, or I mean it's not complicated, but why should I put so much of effort? But the thing is, there is no other alternative to allocate a two-dimensional array where both the rows and columns are the values are known dynamically or during runtime, and you go for allocation also in runtime. So there is no other option. But the nice thing is, even if you do it in a such a non-trivial way, seems to be, but still you can use, once it has been allocated, you can still use the aij or either the pointer notation or the array notation, and the logical contiguity remains. So they are not physically contiguous, but the logical contiguity remains. Okay, and that is a nice thing to see here. This is all that is done. I am just skipping this part. So now, okay, this is again I have to delete this one. So now this is the case. So R is known and C is unknown. So can you tell me the solution? So how to approach, how to write this code? Now I've explained enough of the things. Now let me see how many of you can answer this. So what I mean is R is known and C is unknown. So if R is known, that means, so C is unknown means, so the number of columns in a row you don't know. So which part probably can be made static allocation in this case?
R, sir.
R.
R means which part? Because there is, I mean, if we recall in terms of the previous one, A and B,
Sir,
there are
the
two
A.
allocations.
A.
So the portion A can be, so the portion A earlier it was from the heap segment. Now we can probably have the portion A. A means that that big A. So that is, so R is known. Say let this R be. So let this R be. So it's a constant known. So constant R equals to say 3, right? So R is 3. So this R, so sorry, not R. So this is the number of rows, but the number of columns I don't know. So it is C in C. I know it in the runtime. Known in runtime or during the execution. So once you know this, so but the number of rows are known to you, right? This is fixed. This is not only known to you, but this is fixed. So once it is fixed, so to allocate it, in the which notation I have used. So to have it in the, so I would like to have it now in the static allocation. So where it should be in the stack segment, right? Earlier you see, earlier it was in the
Heap.
see earlier it was, this was a part of the heap, right? The heap segment. Can you see others? So now I would like to have the allocation of that space in the, sorry, in the stack segment. So that means it should be a static allocation. So what should I write here? What are the elements here? What are the elements of this array? So this is an array which should be statically allocated, and the element should be integer pointer, right? So what should be the statement here? Tell me quickly. Hello.
int asterisk a bracket
Int
S-
asterisk
a
a, yes, a
bracket के ये square bracket inside it r.
r. Good. So this is what it means. So this is static allocation, a normal allocation. So this is a static allocation of one dimensional array of integer pointers of size r, which r is fixed, right? So this part is done. So
Yes.
that so once this is done, now what you have to do, you have to now allocate. So maybe the value of c you have assigned here 2, you have entered here 2. So these two, these two, these two, like this. So you have to allocate them individually, but where from they should come, because you have known the c right now. So you have to do it, you have to request it from the which segment? These all will be from the heap segment, because they need to be dynamic allocated. Okay, so again the code is very simple. So this means you have to write, so you have to do it one by one, right? So here you have to write for I equals to 0, I less than, how many of them are there? How many of them are there? Equal to the number of rows, so I plus plus. Then what should I write to allocate each of them one by one? New. What are they? They are of type int, int, int. Each of the size, each of size 2 2 2, because say, or size c each, right? What should I write here now? New. It is just the same as the previous one. What should I write? Hello. What is my intention? My intention is to allocate a one-dimensional integer array of size c. That's all. So why we are taking so
int
much of time?
square brackets int square brackets int square bracket c.
C. Where should I assign it?
A of I.
A of y. Okay. So that this points to this points to this. Sorry, this points to this, and this points to this. Is that fine?
Yes, sir.
Yes, sir.
So can you see the difference now? So earlier, because it was not static, this was also dynamic. You need to have another additional pointer variable which will be pointing to the base address of this, and that pointer was in the stack. That was a static allocation. Just that pointer variable is statically allocated. Now, because you know the size, this whole array of one integer pointers is static. So this is static allocation, and you can name it as a. That's all. You don't need another additional pointer to point it. So it itself is an array, but you actually you allocate dynamically these arrays. Is that fine? Hello.
Yes, sir.
So let us come to this part. So this is what it does. So this is, say, you can say this is the part A here. This is the part A, which is basically here static, and this is the part B, the same part B, but this is now only dynamic. So this part B is only dynamic. The rest of the things are all same, except the deallocation. So during the deallocation, which part you have to deallocate? All that you have dynamically allocated. So only this much is required. So this is D or D1 is there, but there is no D2 because this is static allocation. Anyway, if you come out of the function from the stack segment, it will be removed, right? Fine.
Yes, sir.
This is what it means. So this I am showing that this is what is this? This is say B. So this is say B. Okay. this is say B. So this is B0, this is say B1. So once you have done this, this is from the stack. So now you are trying to allocate the rows. The first row, this is say row 0. So row 0, it will be assigned to B k equals to 0. So this will be pointing to this one, right? And then you will take the next value of k. Okay, so let us complete this one. Next value of k and will pointing to this one. Okay, so now, so these are row 2, sorry, row 1, and this is row 0. So this will point to this one. Fine. So now when we deallocate, it will be deallocating this first and this first. Next, can you say what about this one? If R is known and C is unknown, R is known and C is unknown. So earlier what was the case? Sorry, what is this? Sorry, R is unknown but C is known. So C is known. So this means this is const int C is say 2. You know always it is 2. But this R is just a variable and you read this here right now. Now tell me, how can you do this? You can always assume that the first approach where both are unknown, and you can try to do that, but this can be done in a more efficient way. Can you tell me what type of pointer you need to declare? So this array, see the point. So this array, the number of rows are all of size same. So this is known, this is fixed. This is not only known, but this is fixed. It will never change. You know that. C is fixed. But this R is unknown. So how can you define the pointer to take care of this? Tell me. With all that what I have discussed till now. Let me see who can answer this. Hello? Hello? No idea? If you enter R equals to say 3, so what does it mean? R equals to 3, but C is always 2, so right? In this case, so R is actually pointing to elements. What are the elements here? So R is definitely a pointer because you don't know the size of the R, right? So, sorry, not R, but so these 1D arrays, need to be allocated dynamically, right?
Yes, sir.
So these 1D arrays need to be allocated dynamically. But how many you don't know? So that's why you need to allocate it dynamically. So you know the size. If you have known how many of such arrays you need to allocate, so that means everything is known you could have done for static allocation. Because you don't know how many of such arrays of size 2 need to be allocated, you cannot go for the whole thing as a static allocation. Is that part clear to you?
Yes, sir.
So can I declare a single pointer? Let me give you the hint. Can I declare a single pointer which will be capable of pointing to elements which are of type 1D arrays of size 2? Can I declare a pointer, okay, which will treat each of these as an element, right? It will treat this as an element, this as an element, this as an element. So because they are all of same nature, each of size 2 integers, right? So they will, so it will be pointing to, or I mean, we can allocate this in a single shot, and this pointer will point to it. Can you declare a single pointer which will be capable of doing things? So something like, as we allocate a one-dimensional array of integers, now I'm allocating a one-dimensional array of 1D arrays of size 2 exactly. I've given you enough hint. Can you come up with the answer? What should be the type of this P? Or say you can call it as A. Hello? Not getting? Hello?
Yes, sir.
Come up with the answer.
Sir, can you repeat it once more?
So my hint was, I can declare a single pointer which will be able to point to an array of these elements. So these are elements. It's a one-dimensional array of these elements. What should be the type of this A or P? Say you call it as P. What should be the type of P, which is a pointer to array of what? Array of 1D arrays of size 2, like that. Can't you recall what we discussed 1 or 2 classes back? If I write this, will it work? Or if I write yes, if I write this, will it work? What is the interpretation? If I declare yes,
So we can declare normal array of size 2. The base address will work as the pointer.
no. Now see, will it work? What is this P? How we did this? What is this P?
An array of pointer pointing to.
No, it's not an array of pointers.
Sorry.
This is P is a
Pointer pointing to an array of
just
elements.
focus on this one. There is a parenthesis here. So as CS students, you should know the the interpretation of a parenthesis. So you should be reading this first without looking into anywhere else. So it's P is a pointer. That's all. It's a simple pointer. P is a pointer capable of, P is a pointer variable because there is no constant, pointer variable capable of pointing to what?
Array elements of exactly size exactly.
Yes, pointing to an 1D array of elements. What type of elements? That each element is again a 1D array of size 2, exactly size 2. Is that fine?
Yes, sir.
See this. Is that okay? So P is a pointer variable. P is a pointer variable capable of pointing to 1D array of elements. 1D array of elements. What type of elements? Each element is each of those elements are one-dimensional array of exactly size 2. Have you got the point? So if I do that, then what do I do to have this allocation so that this points to this one and I have got this much? See, what is this? So there are these boxes. Okay, so if I call it as yellow boxes, so these are yellow boxes, right? A group of 2 yellow boxes, but that is packed outside by a green box. So what should I write here? P equals how much? What? new of, what do I write? Int, tell me. Here I can write here C, right? Because this C means C is 2. What do I write here? So here this is fixed. And this is basically this one, you read it like this. So this portion comes here, right? And this is the one that you are passing as a variable argument, the number of rows, which actually varies. What the point? Here also I specified the type. This is the type. Is that fine? Are you getting this?
Yes, sir.
So what is the difference between this one and the previous one in terms of the allocation scenario? In the previous two cases, the different rows, the 0th row, the first row, the second row, are they physically contiguous?
No, sir.
But in this case, what do you expect?
Physically.
So it is not only that this 1D array, this will be physically contiguous, but you say that you are basically treating them as an element, and you are trying to say that how many such elements are there. So it's basically a 1D array of another 1D array of 1D elements, like that. So you can expect physical as well as logical contiguity of this array. So it is more something like that of the static allocation. I mean something similar. But the thing is, you should have a pointer which will be pointing to the base address of this green box. Okay. So this is what it means. Can you see this? So this is the pointer to this blue yellow box. So this is the row 0, this is the row 1. And you see, this is a nice thing to see that these are physically also contiguous. Definitely logically they will be contiguous, because if you write here this here I have used the pointer variable name D. So D0. So what is this? You see what is D? D is here you are. If you write D plus 0, where you are still here, right? Hello?
Yes, sir.
If I write D plus 0 asterisk, where you are? Right? You are here. If you write plus 0, you are still there. If you write another asterisk, then you are here, right? Got the point? So this is basically D00. So even in this case also, if I write Dij, you are basically the same thing. You are getting access to the ith element. Is that okay?
Yes.
There are no other voices. Are you getting things? This is pretty simple. You just try to think of it. I mean, the only problem is if I discuss it in the class, and if you don't go through that before the next class, then this becomes really difficult for me. Because it is quite obvious that you get confused. Is that clear? Others? I am talking to others. There's no. I still have doubts whether it will work or not, or
No,
what
sir.
is the problem? Hello.
No, sir, no doubt.
So if you have doubts, you can ask me. You can just say that, okay, why don't I do this? What is the point of this? I mean, few things you have to do it of your own. You have to take a machine and you can type things and try things, and you can learn from the errors to know it, to get yourself convinced. But some things you can always ask me, and I can try to clarify it before that. And what about the deallocation? Because it points to the whole chunk, it's an array of this. So how many steps of deallocation? So because allocation is done in one shot, deallocation is also done in one shot, right? So if you just write D of this, the whole chunk is deallocated all at once. Is that fine?
Yes, sir.
Yes, sir.
So we have basically discussed about three possibilities. One is where the rows and the columns are not known, that we have done in the previous class. We revised it in this class. In this class, we basically talked about when the number of rows are known but the columns are not known. So that is that integer pointer array you declare in the stack segment and the rest you do it in the heap segment. That is one possibility. The other case is you have got the columns known but the number of rows are not known. This particular case where you can do it even more in a more compact way, where you declare basically a array. It's basically a single pointer which is capable of pointing to elements of size of one dimensional array of size, say C. And this is how it is done. So contrast to the previous two cases, this case is that the rows are physically contiguous as well as they are logically contiguous, because this is how it is achieved. They are logically contiguous and physically contiguous. But the previous two cases, they are logically contiguous, but they are not physically contiguous. Okay, so this notion of physical logical contiguity. So in a classroom, when you are sitting, so do you necessarily sit that roll number 1 and roll number 2, roll number 3 like that, one after the other, in a physically in the same sequence? Hello?
No, sir.
So generally in a normal lecture class, but if I call roll number 1, the roll number 1 will respond. Roll number 2, not necessarily that the next person immediately next to him will respond. So he will respond. Roll number 2 is sitting in the last bench. He will say yes, sir. Roll number 3 is in the third bench. Yes, sir. Like that. So see, when I'm calling the names, you are preserving the logical contiguity, right? Hello.
Yes, sir.
So this is logical contiguity,
sir.
but the physically you are not contiguous. But can you give an example where things are you people sit logically contiguous as well as physically contiguous? In what situation? Generally during the exams, right? During the exams, your seat numbers are not, you cannot sit anywhere. So it's like roll number 1, then 2, then 3, then 4, like this. So there you sit. So there you are physically contiguous as well as logically contiguous. Got the difference?
Yes, sir.
So I think there are 5 minutes left. Now, can you quickly tell me about this case where, so it will not take more than 5 minutes. It should not take. So try to answer it fast. So R is known, C is unknown, but C is different for different rows. How to tackle this situation? So the case is like this. Say C, so R is known. R is unknown. R is unknown. So C is unknown, but C is different. This is, say, this may be 3. The second element might be 2. The last element might be 1. And the fourth element might be 5, like this. So this is R. So this is C equals to 4. This equals to 2, C equals to 1, and C equals to 5. For R equals to 1, 2, 3, 4. For R equals to 4. So here, this is a situation. Can you just quickly tell me what should be the code here? Out of the 3 cases, which one should I follow now? Both R and C unknown, R known, C unknown, C known, R unknown. So which one should be, which template should I use to write this piece of code?
Second
the only thing
one.
is option. Which option? Hello? I think there is some.
Sir, R unknown, C unknown.
R unknown, C unknown. Fine. So let's see. So R unknown, C unknown. So what should be the declaration then? What is the declaration of this array? So the thing is, I have to know. So R unknown, C unknown. So this is this, and I have to have this, which will be pointing to this, and they will be pointing to. So the only difference is here it is 4. Here it is say 2. Here it is say just 1, and here it is say 5. Right? So what about if I call it as P? So what will be the type of the P? What should I declare now first? Int. So these are integer pointers. These are all integers, simple integers. These simple integers, array of simple integers, simple integers. So which part will be in the heap segment? This whole part will be in the heap segment, right? Dynamic allocation. And this part will be in the stack segment. It is a static allocation. So tell me how I declare the P. What should be the type of P? What is the type of P? P should be a asterisk. So first of all, I would like to allocate this part. What should I write here? Tell me quickly. P equals
New int s
New int
s
asterisk.
square bracket
Okay,
r.
let me do this. Int r comma c in sorry c. Okay, what should I write? Int r. Then one by one this one. So for I equals to say 0, I less than, tell me quickly, r, then I plus plus. What should I write here? Now here, sorry, so the point is here I cannot read C here, like, right? Because there is not a fixed C. C is unknown, but C is not fixed, so I cannot read it prior. Okay?
Sir, isn't the value of R already known?
No, value of R is not known. I have read it in the runtime.
Oh.
I have known the value of R in the runtime. C also I could have known here, but C is variable. So each time before I allocate a particular row, I should ask the number of columns in that particular row. So I cannot read C here. Definitely R is not known prior. I am reading it in the runtime. So inside this loop, what should I do now first? What should I do? What should I do? I should read the number of columns, the 0th row for the first row, second row, like this. So C in, what should I write? C in. Hello? What should I write? I should read the number of columns. Okay? Again, no answer. Are you getting things?
Yes, sir.
Okay, so what should the next statement then? P of I equals new of
New
Square bracket
new
c.
new int
Square bracket
what is the value?
C.
C. Will it be enough? Now you have read it and you have done it. So you go for the next 0th, 1th, 2th. So is that enough? So if you allocate space for only 4 elements and here 2 elements, so from here, once it is done, once you are outside the for loop, can you know how many rows are there in the first, how many columns are there in the first row or in the second row and the third row? Is there anywhere you have stored it? Got my question? No. So you lost everything. So if you don't know it, when you are reading or displaying, how can you know that when I equals to 1, how many elements are there? I equals to 2, how many elements are there? So what to do it? How to do it? How to solve the problem? Are you getting the point? What I am raising?
Yes, sir.
Yes, sir.
So tell me the solution quickly. Do it
So
fast. I want some.
So we can keep an array of size R.
Yeah, can I do it inside itself? So why should I have an additional array? Let it be a part of this data structure. So what can be the solution? Yeah, that is definitely possible. So what can be the other solution?
Sir, for the each column, for each row, we can keep the topmost element for that.
Yes, this is what it means. So then how many elements do I have to then allocate here instead of C? It should be
C plus 1.
C plus 1. Everybody got the point?
Yes, sir.
One
Yes, sir.
additional element to store the number of column elements, right? But again, you might argue that okay, if it is a floating point array, then how could have you stored it? Even if you say that okay, I can typecast the float, I can typecast the integer as a float, and somehow I'll interpret. But the thing is, if it is a character array, you don't know what to do. If it is a something else, so the problem is not a this is not a generic solution, but at least for integer arrays you can do it like this, integer and float. But for other type of arrays, probably you have to do that part. So you have to have a separate array of integers of equal size equals to r, and you have to store it there. Is that fine?
Yes, sir.
Yes, sir.
But now it's easy for us, and so here once I do this, can I go for, so what should I do now? Once I have done the allocation, I have to store the value of c before I go and take the next value of c. What should I write here? What will be the next step before the iteration completes? What should I do? 0th element of the ith row should be containing the value of c. What should I write? Are you not getting things? Hello? I have to store the value here. I have to store here 4, I have to store here 2, I have to store here 1, I have to store here 5. That is what I have decided. What should I write here?
Sir, Pi0 is equal to C.
Yes. Store the column number, right? Is that fine? So the rest of the things are very simple. I mean, then once you have done that, so when you are accessing the values, what should you do? The ith element, how to access the ith element? P of I. What should be the ith element? P of I. Will it be j?
J plus 1.
J plus 1.
J plus 1.
Is that okay? So this can be one problem where you see there are number of departments. Say for example, in our NIT Durgapur we have got say 10 departments or maybe 7 departments, undergraduate departments, and each department they have got varying capacity of the students, right? CS this time it has got almost like 180 students. EC probably has having 150 students, but civil engineering they are having probably 80 students, like that. Mechanical they have got something more. So that also varies in different years. There are different intakes and all. Okay, somebody left. So the thing is, if you would like to store the marks obtained by each student, or maybe the CGPA, say for example CGPA of different students of different departments, then if you think that okay, let me allocate a 2D array of size say 200 cross 6, that will be a sheer wastage, right? If you have a 2D array of say this is 200, because you know the maximum number of students in a department is 200, but you have got only 6 departments. So if you do that, so this is for CS, this is for mechanical, this is for ECE, this is for civil, and this is say for metallurgy. Okay, so for the computer science it is fine, it is there more or less filled up. For the mechanical this is also fine, but for the metallurgy, okay, the metallurgy they will be filling only this much. Okay, for the civil they are filling this much, for the biotech they are filling this much, for the EC they are filling this much. Are you getting the problem? So if you have done a simple allocation of 2D array of considering the maximum student size, so these white portions are allocated but they are not utilized. Are you getting the point? Are you getting the point?
Yes, sir.
So this
Yes,
is
sir.
students and this is the departments. So this is a much better option, because once you know dynamic allocation, you should be trying to utilize the space in a best possible way. And this is, so instead of doing that, I'll be probably doing this variable allocation. And in fact, this will be useful while we will implementing hashing also. So I'll be talking about it later instead of complicating things right now. So this is a summary. So this is what we have done here. Okay, this is done, and we are using here one extra for the column numbers, and the rest of the things are same. So still you can use the same notations. Okay, so there is a mistake here that I have made once again. So this will be j plus 1, right? And this will be j plus 1. And you see here I am plugging the, while I am displaying the contents, so it is E10, but it should be j plus 1 and it should be j plus 1. Is that fine?
Yes, sir.
Any doubt at this point? Okay, I'll change these slides before sending. So this is a summary. I think that is what we discussed till now. Just have a look. And before I end up, so just tell me that what will be the size requirement for this each. What is the size requirement? What is the size requirement here? It should be, so if each element takes 4 bytes, it should be R into C into 4, right? That will be a size. The total size that is allocated out of heap or stack, whatever, together. What will be the size requirement here? It should be 2 bytes for this one. What about this one? How much consume it? It will consume here. How many elements are there? Hello? R into 4 plus how much here? Each of our rows are having 6 column elements, and each of them they are occupying 4. Is that fine? So these are total allocation in this scheme. What is the allocation in this scheme? Sorry, how much of space required? How much space required here? R into 4 plus
I into.
Is that fine? Got it?
Yes, sir.
I'm not getting your voice. What about the last one? This one, the typical one. It should be 2. This is for 2 plus this one is R into C into 4. Got it? So this is exactly similar to that, but the only thing is the actual allocation took place in the heap, and you just need a pointer to keep track of the base address. See, and though that pointer just takes 4 bytes. So this is almost similar to this one. I mean, the allocation that it took place. Is that okay? Any doubt till this point? And what about this one? This one will be 4 bytes plus R into 4 plus, tell me first, R into hello. Is it not yet clear? What is the space requirement here? This is 4. This is R into 4. And what about this one? R into? Hello?
C.
Huh? C. R into C. Is that okay? C plus 1 into 4. Because one element is used to store the column count. Got it?
Yes, sir.
That's the end of this class. These are some of the assignments. I'll officially announce the assignments maybe after Monday, because I'll add some assignments using references also. So these are simple ones that I've already done. So this is the last one you see, rows having variable number of columns, the number of students and departments. Okay, so this one I have just now mentioned, so you can just utilize that. This is dynamic allocation of 2D arrays where the number of rows and columns are unknown, R and C both unknown, the typical case. And this is for one dimensional array, but here you have to implement heap. Using that one dimensional array, you have to implement the algorithms for heap insertion and deletion. Do you know what heap is? Heap data structure. Heap data structure. Heard of it?
Yes.
Yes, I think it has been taught by in your data structure class. So if not, I'll be discussing it in the tutorial, Tuesday tutorial about the heap. So this is an example where you need to use one dynamic allocation of 1D arrays, dynamic allocation of 2D arrays, and here dynamic allocation of 2D arrays with variable number of columns and rows. Okay. And here matrix multiplication is trivial, but I would like to have the determinant also, and determinant you have to write a recursive code. So there we'll get to know the recursion also, right? So if possible or if required, I'll discuss about the heap and I'll discuss about the finding the determinant of a matrix. But the rest you have to do. And Monday I'll be talking about the reference type, how it is different from the pointer, and how references with constants work and all this. Okay. Any questions? But I have not yet received. I think everybody has got the account in Moodle and they have checked that. I have pasted all these assignments in the Moodle.
Yes, sir. Both are there.
So,
Sorry,
but I have not yet seen any submission.
So we'll do it today and tomorrow.
Okay. If not all of them, but at least a few of the submissions I expected by Sunday or Monday. Try to do it, because you see, as CS students, just solving 2 or 3 problems, I mean codes, writing 2 or 3 codes a whole week, this is really not expected, because that is your business, right? That is what you are meant for. So no matter what you do, you have to write at least 8-10 codes per week. Otherwise, you will not be able to develop the skills. I mean, it doesn't matter, because many of you are busy in competitive programming, I know, but this is also a part of the curriculum. So try to write as many codes as possible. Otherwise, your skills, because programming is all about skills. Apart from the logic itself, it's all about brushing those skills. And without much practice and applying those concepts, it's of no use. It's not a theory. It's like mathematics. Even if I keep on explaining months after months, nothing will happen unless you try it yourself and see that whether you can apply those concepts appropriately. Okay, any other questions? Any question?